Thank you for joining this talk. So let me present myself. My name is Olivia Quinet. I'm working inside the R&D department of Cluepons. Cluepons is a small company specializing in analyzing data from a clinical trial. I guess you all know with the COVID vaccine what is a clinical trial. So I won't speak of that. So let's go back to the talk, which is about experimenting with type erasure / external polymorphism in C++17. So, in fact, I was working on a project, and I remember that there was a lightning talk in Meeting C++ from Anna, I think. She said, if you have a nice project and you want to present, submit a talk. And here I am. So, let me present my project, which is a SAS file reader. So what's a SAS file? It's a database storage file created by the SAS company, or SAS software, and it contains binary encoded datasets, so tabular data, for advanced analytics, business intelligence, data management, predictive analytics, and more. And the more, in fact, is in clinical trial, a lot of the data are stored in this type of file. And so why did I decide to do this project is because, yes, there is a lot of SAS reader available, of course, the official SAS reader. There is a C reader, there is a Python reader, an R reader, a Julia reader, but there was no C++ reader. So, or I didn't find any. So I wanted to program one and see or and compare my implementation with other implementation. So, and first, I know what I didn't want it to do. It's to have this line of code where you have on the left side the dataset and a function that just reads a file that you give the path. I didn't want it to do that because I didn't want it to manage a dataset or data frame, which is a very, very complex subject. And most of the time, maybe your implementation you are going to give is not what people want. So I didn't want it to have that. And it clearly lacks flexibility. You cannot, with this, you have to read the whole file. You cannot access part of the file and things like that. So that's not what I wanted. So what I wanted is to abstract the file and the dataset. So for the file, I have a source, a data source. And for the dataset, I have a sink when I will drop the data. So the data sink. And of course, you can have a filter, so you only want part of the column of the file. So you want to inject a column filter. So I wanted to have something more like this, where you have a reader, you pass the source, the sink, and the column filter. But how to do that? So obvious solution is to create a virtual base class, an interface, and then you derive the source, the sink, the column filter from an interface you propose. But then how do you pass the derived classes? You want to pass them by reference, but then you have a lifetime problem. You want to pass them with row pointers, but that's bad. Maybe smart pointers, but that was not good. You still have you still create dependency because you have to derive everything from a base class. So, and then I remember a nice talk from Klaus, which has Breaking Dependencies, type erasure, a design analysis. So, and I say, why not use this for my project? So, and I will try to show you how I use this pattern for this project. Of course, there is a lot of type erasure pattern. There was another one presented in the C++ weekly episode by Jason Turner, but it is quite different because it's using lambda to map the object and access the method. So it's more like a view on an object. But I won't speak of this pattern. You can look in this episode. It's very nice too, but it's a complete different techniques to do type erasure. And yeah, it's There's some advantages, but disadvantages too. So, what is type erasure? So, I will go back to the original paper from Kliss and Douglas. So, this pattern allows classes that are not related by inheritance and have no virtual method to be treated polymorphically. This pattern combines C++ language features with patterns like adapter and decorator to give the appearance of polymorphic behavior on otherwise unrelated classes. So, and I will take the example from the original paper to explain to you the idea that they presented, and it's a screenshot of their paper mostly. So, the example they wanted to do is to dump or print the state of object in memory for debugging, and the object could come from the code they write or from external libraries. And so, of course, there's, again, a different option to do that. You can think of derive all objects from a dumpable base class, or you can also use a brute force solution to register all your known type inside the DB object, or you can use the external polymorphism. So I will show you. So you have the first solution, so with the base class, the tree-based solution. So you have the dumpable with the virtual dump, that is, and you can register this type of object inside the object DB, but you have to derive all your object for that dumpable base class. So, of course, it's quite easy, but might not be feasible all the time because it requires access to the source code. All the class needs to inherit from a common root class, and of course, it may change the layout for holding the V table. So you cannot use concrete type with this. The brute force solution is to adapt the object DB, so you have different register function to store all the objects you want to dump. So it, of course, eliminates the need for common ancestor, but on the other hand, it's tedious maintenance, it's error-prone, because a lot of cut and paste, and you might have some integration difficulties with different type and things, so it's not easy. And the third solution is the external polymorphism solution. Again, you have a dumpable, but then you derive a concrete dumpable as a template that will contain in their paper a pointer to the object you want to dump. And then the actual dump function is delegated to an adapter. So it's more or less the code they presented in their paper. So you have a collection of dumpable, and via virtual function you call the adapter. So it looks nice, transparent, flexible, peripheral, because you can inject any type, but there is a lot of boilerplate. So, and it's not that, yeah, there is a cost attached to this technique. So in summary, so for example, you have a concept with several methods, and you want to link it to a particular implementation with maybe not exactly the same method names. That's why I introduce here underscore between method and one. And you have a model that takes, a template model that takes the implementation as a parameter, and you have an instance of that implementation inside the class. So the virtual method are funneled in the model, and with the adapter design pattern, you link this virtual final method to the actual implementation. And if you want to go to the actual value type semantic, you have to create an instance via the Pimpl or bridge design pattern. And so we'll wrap everything nicely. And so, but of course, you have the method one that will call the virtual method one, then the adapter, and then the actual implementation method one, and so on for all the methods. So that's it. But we have a value semantic object that can contain any type of implementation as long as these two methods or the methods in the concept are implemented. So in summary, type erasure enables to use various concrete types through a single generic interface, and it can be compared to duck typing in language like Python. So, apply to our reader. So, you have a constructor with the different type. So it allows you to write something like that. So you have a data source and a data sink. So a data source will read a file, and data sink will be a CSV file directly. So you write it, and here you have read all, so it will read all the rows, and so it's converting a SAS file into a CSV file in one line. And so, and depending on the method that you provide in the reader, you can use different things. So, and now that is the experimenting part. So now we have the goal where I want to go, and I will show you what happened. So for the data source, again, it's to think what we need for the data source. What is the method that we want to have for the, yes. So we want to read, of course, bytes from the data source. So we want to read a certain amount of bytes and put them in the buffer. And we also want to know, did we reach the end of the stream? So that's more or less an easy interface. So anything that can implement this, it will be good. For the data sink, that was a bit more complicated. So the data sink, so you must know the properties of the file, so the different columns there is in the file, so we can process them accordingly. You must know the header, the metadata, and so on. So we need to have a method that will tell the sink what are the properties of the file. So do whatever you want with it later. And then we are going to push the row of the dataset one by one. And then at the end, we have to tell the sink, okay, we are done, end of data. So the properties for the SAS file, the SAS file is quite tricky. So it really depends, the encoding really depends on the initial platform. So it can be 32-bit, 62-bit, with little or big independence. It can be Unix or Windows. There can be some compression and so on. And it creates a lot of different offsets inside the file, depending on all those options. And for the column, so the column, they can have a name, a label, a format, specific format, and there is more or less a fixed, finite set of type, which is string, number, integer, date time. And I also put unknown just in case something new, unexpected happens. But you have to know that even if the number of type is finite, the way they are encoded in the file can vary. Sometimes you have an integer on 1 byte, 2 byte, 3 byte, 4 byte. And the same for number. The number of bytes that can be encoded can vary for 4 to 8. And yes, you have to tackle all of that. And so a column have a formatter. So again, I use the type erasure concept with, for the formatter, which help format, in fact, the raw memory to the final type that you want. So that's the column formatter. It can give you, depending on the type, you can call one of those 6 functions. So you can get a string, a number, an integer, date time, and so on, and also edit a method to transform your type to a string. And you can also retrieve, for example, the maximum length of the colon, which could be for a string, the maximum length of the string. And for the colon filter, in fact, the concept is quite easy. You say simply, do I accept this colon or not? And pass the colon to the model that is provided by the client code, and it accepts it or rejects it. So whatever the rules are. So it's usually you have most of the implementation, you have include only this or exclude those, but you can think of any other rules. And for example, I include only integer colon, but you cannot do that with the actual Python or R reader. So it's just based on name. Here you can do any rules you want with this. And so I follow the concept and model design pattern from the Klaus presentation. So in short, for the data source concept, so we have these two functions that I showed you before. And then you have the data source, which is a template. And you have you have the source object at line 19, so which is directly constructed by perfect forwarding. And in this case, I call the read byte on the source and the end of file on the source directly. You can do something else, and I will try to show it to you a bit later, what else you can do too. So what is different is I define directly a unique pointer. So for the source, and also a build factory, so it's a bit easier to conceptualize what you are going to do. And yes, so that's the original constructor for the reader function. So I have all the type, and I construct. I'm using the different build factory to have the smile pointer to pass to a protected constructor, so that I completely separated the construction of the different entities from my reader. And I also use a private implementation for the reader, so everything is separated from the header file, from the actual private implementation. So I will show you, yes. So for the reader, that's the actual definition of the different default constructor and destructor. Then you have different methods that are useful for the reader, so you can retrieve the properties. You can also signal, okay, no, I want to stop reading the file, stop, end of data. I want to skip some rows. I want to read all the rows. I want to read only one row. I want to read a bunch of rows. And the read row knows things. It's a bit of a hack, but they give you directly access to the row buffer. So, and the current row index gives you the position in the file that the reader is. So that's the private implementation, and why I needed to define those reader there with default and not in the header file. It's because you have a unique pointer, and if you define them in the header, you enter some problem with they might not all be accessible, especially the imp class for the reader. So you have to define them there in the CPP. So you have only one point where everything is managed for the Pimpl. So again, for the data source concept destructor, virtual destructor, you have to define them there. And then for the protected reader, it's simply constructing the Pimpl, so the private implementation, through a build factory function, which do the work. So It's a bit weird here, but I will tell you why. So read data. In fact, just read the header and the metadata of the file. And that's why I pass properties 2 times, because in the one it will catch to the header part, and the other one it will catch to the metadata. And then it will return a variant to a reader template, but with the correct endianness, compression, and platform, and everything. So after that, I use the visitor pattern to create the private implementation for the reader with all those parameters correctly set. So at the end, I have all the offset correctly set into forwarding the file. Okay, and the rest is just passing all the properties to the Pimpl, all the methods to the Pimpl, and that's it. So if you're interested, I will show you the structure of a SAS file. So you have a header with some magic number, then you have the endianness, alignment, and things that you have to read, the metadata, and then you have a list of page that you can read with data. So in fact, you have to check for different things, of course. Is it a valid file? So check for the magic number, then you check the endianness, the format for 30 or 62-bit, the alignments. You take all of that, you read the header with now 2 parameters, 2 template parameters, Indian and format, and then you hit the metadata, which give you the compression, and then you read the read data, which is a template structure that helps you read the whole file, and everything from this template parameter you can get all the offset correctly. So you don't have to do any if then else inside the code, as in many implementation of the SAS reader you can find. So and so yes, so testing. Testing was, of course, a bit easier here in this case. I will show you. Because you have all the components are, in fact, quite independent of each other. You don't need an actual source. You don't need an actual sink to do all the testing. You can test everything directly. It's more or less having some, you can call dependency injection, because for your test, you can create mock easily in this sense. For example, it's easy to create in-memory data source or a null sink because you don't want anything. But, of course, also I wrote tests on actual files to test all the encoding, compression, and endianness option. So several, it's about 80 megabytes of data in 170 files. So, in the original talk from Klaus, the concept manager class I declared private. So, I heard recently that he made a note about that. It's updated talk. So, the fact that they were private makes it harder to test them directly. So, and particularly, I like to test every part of the code because I know myself, I do cut and paste, and I make errors. So I want to test all the abstraction levels. So at that time, it's one way to overcome this is to create a public smart pointable factory to test them, but there is another way I will show you, or you can also have, in fact, that's why you can place everything into a detailed namespace. I know there is some people that doesn't like it, but that's one way. You can do whatever you like here. So also, in the original presentation, you have this type of call. So the virtual final method in the model class is using a free function apply on the model. But then if you do that, it cannot compile. And you have an error because it cannot find it. And that's a bit annoying. So there's a different way to overcome this. Either you call the method and you prefix it with namespace where all the methods need to be implemented. That's one way. But then you cannot define a friend function inside your class, because then you won't be found. And also, it would be nice to have some kind of techniques to call, okay, I want to apply this method on this object, but please first check if this method is present in that object or call the free function with that object as a parameter. So that's more or less the idea presented by Iglberger and CPPCon 2022. Can C++ be 10 times simpler and faster? One point I remember is say, hey, I have this, it's funny, it's nice. And yes, I really like the idea. So that is the one way, so you qualify the method where all the implementation needs to be defined. So before going to the next part of the presentation, I would like to show you something inside Compiler Explorer to maybe, because I know I really like when I see code and it's running, so we'll try to show you the actual experiment. Oh, can you read? Okay. So, c'est petit à l'écran. So yes. So that this is quite anti-implementation, but stays more or less all the functionalities. So I didn't place here the colon filter because you don't need that. Just a nice thing to have, not exactly. So you have the template, source and sink for the reader. You build it. That's a protected, and you move it into the source and sink. So yes, and here I use the detail. So for the source you have the two functions. For the model you have the two functions, and here I use the read bytes and the file. So yes. And same for the sink here, I only define the push row function. So, and so this is a small test I will show you. So we have the reader with the source and the sink, and I say there is two rows, so I can read one row, two row, and the third row, of course, is false. And so, and here's something you can create like this. So for the source, you have number of rows that you want to read. Format the buffer, so read bytes, the number of rows that is in the source. So you have the output here, 2, 1, decrease number of rows, and then for the end of file, well, just as long as there is row, we are not done. That's why you see. Okay, for the sink, it just push print row on the screen. So, and this is where the adapter function resides, so in that namespace. So just making the call, and so on. So it's good. But for example, can you use a type coming from the STL? For example, the EF stream. Yes, so you define that EF string, the reader, and you simply, sorry, read from the string for the stream, and you return true if it's good, and for the end, well, if it's not good, you are at the end, or if it's reached the end. And so for the tests, the second test. It's simple. So you have here, takes directly the type. Sorry. So you have the string, getUpals, and for the string, I just created the same one. Yes, and yeah. And of course it fails, because you cannot read anything on Compiler Explorer. The file doesn't exist. So that's why it fails. So that's more or less the idea. I don't know if you have questions at this stage, or do you want me to show you some more stuff about this? No? Okay. Okay. Yep. So, next part. The string, yes, of course.
That's a much better phrase than eating my own dog food.
Yes, so I wanted to know how good were my interface. If, for example, I wanted to use it to write a Python and R wrapper package, did I encounter some difficulties that I did not foresee? So, more or less, this is the same diagram that can be used for Python and R. So you have a read as function when you pass a file name, a thing, and the filters. And yeah, so you have the reader. And in fact, that call will instantiate, will create an instance of a CPP class that will reside in the Python or R namespace, because you can do that. That will be, in fact, one of the only C++ class that will reside in both domains. And that class will analyze the parameters that are passed to it through a factory method to see if the actual thing, which is a Python object or R object, has the correct methods. And so if it has the correct methods, then we can create an underlying thing, C++ thing, that will have a link to the Python R object, and we'll call that object. What I didn't do in this, for this wrapper is to have a data source, because I just wanted to try for the thing, because that's the most important thing, and usually most of the time you read the file, you read the SAS file from the actual disk. So I was just using my own data source object for that. And so everything was fine, it looks okay, except that the performances were bad, because communication between the different layers, C++ and Python or R, is in fact slow, because you have to do a lot of data conversion. So the push row, not so much. So it's better to read by chunks of rows, or in fact reading the whole file and then creating the data frame in the default type that is available in those languages. And for this, at that time, first time, I didn't have the end of data method for the sync or the reader. So that's the methods that I need to add in my initial design that I completely forgot. I showed it to you in the first part of the presentation, but it came at a much later stage when I tried to implement those wrapper. So, which I think it's always good to test your library for real use case, because it makes you, hey, forgot something. And so now I have this, so you can have the reader, and you can, yes, the C++ thing still have a push row, but the Python thing or the R thing has push rows. So because you are going to send a bunch of rows back to the sync object in the R and Python language. And then, yes, it works fine. So it is the code for the Python wrapper. So you create, for example, a sync by row or sync by chunk or sync full data. So depending on the type of chunk that you want to create, this is the default implementation, but you can do your own Python implementation for the sync and just create a sync that the user can use directly that will create upon that data frame. But you can use whatever you want, in fact, as long as you have defined the correct function in Python for that sync. So, yes, you have this, you can read, and in the sync you will have the properties of the file and the data frame. And it's quite easy. And of course, you can, for example, read all the file or read part of the file. You can skip and whatever you want. It's quite easy. Same for the R wrapper. It's more or less the same syntax, but in R. And so now I wanted to see and do some benchmark. So I took two files that were quite big. In the first file, there was a lot of columns of different types. And the second file was a lot of rows, but only 2 columns. And I did some measurements. So the first line is the C++ code, native, how long it takes to read the whole files. Second line was the Python implementation, the Python wrapper, the R wrapper. Then there is the Julia implementation. Readstat is the C implementation. Then there is the SAS reader from Pandas, and the Python library that can read SAS. And so yes, I'm quite happy with the result, I have to say. Even for the wrapper, they're quite good in comparison to the other libraries. So, what I learned in this project. In fact, I had to look for name resolution, ADL, because I had some problem with it. So, like, is it better to call directly the member function or to call a free function? I'm still don't know exactly where I stand on that one. I think that the free methods might be better, because then you can really use concrete type or other type. It's nice. But then you have to, the user of the library of your code need to define the adapter method in a particular namespace, for example. So it might be a bit too much constraining, I don't know. So that's something we can discuss. But yeah. Also, I realized that I'm a very big fan of testing. If you cannot test something, it's bad design. So that's why I had to introduce. I needed to either separate the concept model class into a detailed namespace and build something factory methods, because it helps you do the whole testing, and yeah, you don't have to create your own object directly, or if you want, you can, go to the type value semantic to another class that will create all those things, but it's about the same. Either you manipulate a smart pointer or use the type directly. It's just a matter of using the dot or the arrow. And so also, I have the question of ownership of the injected created object, because they are injected into the reader, but you cannot get them back. So it's a bit harder to get them back. So you have to somehow have a reference to those objects, to what they are manipulating. So, yeah, it's nice. But, for example, the data frame, the sync, in fact, if you want to use an external data frame, you have to pass a reference to the data frame you are going to complete inside that sync. So is it good? I don't know, maybe. It would be nice if it would be possible to retrieve the sync at the end, a bit like in Python. Python is possible because, yes, but here it's a bit different to retrieve the actual erase type. it's possible, but it's a hack with a dynamic cast and things, so I don't know. So, yes, so that's the end, a bit shorter than 1 hour, but that gives time for question. And I would like to thank you.
So, first of all, thank you. And I owe you an apology for the mistakes on my slides. So the ADL problem, indeed, I totally overlooked. Yeah. So when I realized the mistake, I felt very bad. And the next time I gave the talk, the problem was fixed.
Yeah,
actually, on YouTube, I put a comment that there is an updated version, but as in code, nobody reads comments. So
yes, it's hard to find a comment in the list.
I just want to confirm that I believe that the free function approach is the better one from a dependency point of view.
Yes.
If you force the dependency into the objects it use, then you have an intrusive design.
Yes.
If you move this out, it's definitely easier.
Yeah.
But then, yes. Of course, you run into the ADL problem.
Yes, that's true.
I'm sorry.
No, it's okay. Thank you.
Well, I guess it's a continuation of the same kind of thing. Methods, I think, are just genuinely unsafe. Like, you can't confirm whether this is the method you actually wanted to extend your kind of class with or not. Like, what if there is like another read bytes that does something else? So it's a bit scary, I think, if you just randomly pull methods. But for the ADL, though, I wanted to check what was the problem with non-namespace ones. So it's like, so that they can use the friend function. Why didn't find the freestanding function like free ADL?
Yes, yes. One way is to change the name of the method. So, but then you add a prefix or something. Sorry. So.
No, but the
yeah.
question was about ADL, the ADL bit. You said you have to qualify.
Yes.
The method. So I was wondering what exactly was the problem. Like why?
Because there is name clashes. So if you use exactly the same name, it will try to first fit it to the name of your class, of the model class. So you have the same name for method one. It will try to match that one first, and then that's not what you want to do. And even if you put the model, it's even worse when you put the model in the private part of your class, then it's also clash with the method of your type object. So yes, so you have to change the name slightly. So put a prefix or whatever you want, but then I think it's a bit ugly. So, and yeah, but it might help. So yeah, it's
Hi, thank you for the talk. So if you have just one reader, I guess it's fine, or one class, I guess it's fine to implement manually or erase type manually. But if you have a big project with hundreds of types, I guess it would contain a lot of boilerplate code,
yes.
and you wouldn't want to do that manually. And there are also a bunch of libraries that provide possibility to raise types, like maybe boost type Erasure or Dino Poly, this non-released boost DI. Did you try any of those? Do you have some preferences?
I look at boost more or less, but yeah, but I didn't manage to do exactly what I wanted to do with boost. So, and I wanted to try actually the whole, I would say, whack-a-mole thing. So, and see how hard it is to really understand what is happening under the hood. So, yes.
So, in the big project, would you write it manually, or you would rather use some library?
Yeah, I would try libraries, of course, but if libraries doesn't fit your need, you may still end up to do your own stuff. So,
just as an additional comment, type erasure is not a particularly difficult thing to do. It's 20, 30 lines of code per wrapper.
Yes.
If you use a library, you can reduce this by perhaps 10 lines, but this is not a lot. But now you have bought into another dependency to this library. So I would prefer to do it myself, but I fully feel with you that it's a pain to again do the same thing, especially if you want to do a little optimization in these wrappers. This is why we all wish for some language support. If you write a concept, kind of describe the requirements, then if some type erasure wrapper would be generated from that, we would all be so much more happy.
Yeah, that's true.
I know.
yeah, that's true, because it's just a lot of boilerplates, cut and paste of exactly the same thing. So, but yeah. Okay. Thank you.